Hi everyone, my name is Frédéric Passeron and I'm very happy to be with you today for this April version of the HP Developer Community Meetup. We'll be hosting today Vishal Sharma, is a lead front-end engineer from Saltwork, and he'll be talking about the divide and conquer with Micro Frontends. Nothing to do with RTS games from Command and Conquer from the old century, past one. Consider this as some kind of microservices, but for the front-end part of the world. So before we start, I will go through very quick housekeeping items, and I will need to talk about a few things. Here we are. Oops, I went too far on this one. So yeah, a few things regarding the program that we are actually hosting at the developer community. So today we are doing a meetup, but there are all other possibilities for you to learn things with the developer community, among which you will find the Munch and Learn events that are taking place on a monthly basis, as well as the meetups. They are kind of thought leadership, vendor, product agnostic talks. For the month of May, I mean, Didier will still have to be doing some housework and find out what will be the subject to be covered for the next month. But I'm pretty sure he has a few ideas in his bucket. Regarding meetups, again, as we are doing today, these are also monthly series, but they're more in-depth kind of approach on the technology. It's usually focusing on open source development subject and other kind of subjects that are relevant. On May 31st, sorry, there will be an HP machine learning development environment and the open source machine learning advantage session that will be delivered by Aisha Godgar Onkar, and I'm very sorry for if I'm mispronouncing his name, is a machine learning developer advocate with Determine AI within HP. So these are the two, I mean, this is the next month's meetup. So obviously, the community is also providing some other, I would say, advantages. Just to precise that if you're interested in knowing what is obviously the agenda for the coming months and of the past sessions, if you would like to see some of the replays that are available on our website, I'm pretty sure that either Denise or some of my colleagues will be very happy to share with you the links of these different pages where you can find the replays and the upcoming events that are planned either for the meetups or the Munch and Learn. On top of this, we're also hosting the workshops on demand within the HP developer community, and I'm responsible for this program. This is my little baby. So if you're willing to learn about new technologies, these are workshops that are available 24/7. They're all free. They're Jupyter notebooks based, meaning they're self-driven. There are about 15 of them that are talking about open source topics from Git and Rust and Python and some other stuff. So please give it a try and provide us with some feedbacks. I mean, at the end of the workshops, which only takes for probably less than 2 hours, mainly in general, you have a conclusion, and in the conclusion, you'll find a link for providing us with feedbacks. So it's very important if you feel like there is something missing, or if you feel that you want to see some new subjects covered, well, this is the place where you can shout out and tell me what you would like to see in some forthcoming workshops. This is the community, so we need to share and we need to collaborate and we need to amplify and contribute as part of the community. So you can join people to invite them to our talks. You can invite people to join our newsletter as well. So it's only a monthly one, so we won't be loading your email with newsletter information. It's only occurring once in a month. You can find some support and you can join discussion on Slack. Okay, we have a dedicated Slack channel, and there are many different, I would say, channel with this Slack environment where you can interact with some of the developers of HP solutions. You can find us on Twitter, okay, under the handle of the HP_developer. And if you're a subject matter expert in any kind of subject that could be covered, either you can provide us with some guidance with some workshops on demand. You can write a blog, or you can participate to a meetup, just like Vishal will be doing right now. And also you can build up some workshops with me. With that being said, I think This is somehow a summary of all the things where you can find all the information about the developer community. And with that being said, I think I can hand it over to you, Vishal, and have a great session. And hopefully we'll be understanding everything we need to know about Micro Frontend from now on. The floor is all yours now.
So welcome everyone. As Fred mentioned, this is nothing to do with dividing and conquering. It is more of a title that how can you utilize the word, or how do you understand the word micro frontends to divide your front-end application and again conquer your application to be with the best architecture and all. So before I get into the topic, a quick introduction about me. So I am Vishal Sharma. So I've been in the IT industry for almost 10 years now, and right now I'm working as a lead front-end engineer in ThoughtWorks. So in my overall career, I've been working in different frameworks, starting with Angular, then moved to React, and lot more than that. And with micro front-end space, like taking a lot of shape, I have been trying to share my understanding by writing some blogs, doing some these kind of sessions with the community so that I can share my knowledge and again get some feedback around the same. So just a quick request, like continue to put your questions in the chat or Q&A section so that I'll try to answer them in between or in the end of this talk as well. So mostly in this particular talk, we'll try to cover three aspects of micro frontend: what, why, and how. And in the end, we'll also go through some of the proposed team structure when you actually want to try to split your whole application into different domains and all. So to start with, the first question I think we need to answer is that why do we even need micro frontends? And for that, to understand that, we have to figure out how does the scaling of an application works, correct? So if you're, let's say you're starting up a new team or new project or even a product, correct? When your team is very small or your problem statement is very small, you don't see a problem in scaling, correct? You just write your code, deploy it, and everything works fine. But when you actually move to a bigger teams, or I would say at enterprise level, that is where you start seeing the problems with your performance, your scaling, and then you start thinking about how can I increase the performance or manage high volumes. Now the scaling part, it does not only rely on the how you are writing code, but more on the team, the kind of team that you are working in as well. So for example, again, you're starting small on the left, correct? You just started your enterprise or your product. As the demand or as the features grows in your product, you actually try to vertically scale the teams. That means add more team members or different type of roles in your teams. But as you grow into a big enterprise, and there you actually start seeing that the whole product is actually growing into different domains as well. And that is where you start actually thinking about how can I horizontally scale my team? And that is where the whole split of different teams starts happening. So that means within a whole product, you have multiple teams. Within this team, you have different roles as well, which is actually trying to talk about or trying to solve a particular part of your whole end-to-end application. And that is where we are saying that microservices are for the backends and micro frontends are for the front end. And that each team is actually handling end-to-end from backend to front end responsibility of a particular feature. So considering this problem and this solution, correct? And that like this is how the whole architectural in the application world has evolved. Like we started with monolith architecture, correct? Where we had only one repository where we had our backend as well as our front end code. And here the idea is not that monoliths are bad anymore, because again, if you're like starting small, monolith is the way to go. And with the isomorphic applications coming in with all Next.js and Remix, they actually propose the idea of having your backend and front end together as well. So monoliths are not a bad design choice. It's just that where and when you want to split or when you want to grow into more of a different type of an architecture. But as you grow again, the backend world started feeling the problems with one service, and that is where the whole idea of microservices came into existence, where we said that, oh, we can divide the whole backend ecosystem into multiple services, and these services can have strong module boundaries. Again, they have independent deployments. That means each team can deploy its own services and make the APIs available. And again, you're like, depending upon what problem are you solving in a particular service, you can actually choose a different technology as well. For example, maybe one service is in your Java world, but in other service where you see that Golang is the best fit, you can choose Golang as well there, and so on. But with microservices architecture as well, we actually starting seeing that even though we have a split of services, but front end remains a monolith, correct? And that does mean that even like as a microservice team, even if my feature is ready to go into production, I am still dependent upon this one UI monolith uh, uh, to actually be feasible for release. Because again, all the different teams are working on the same monolith. They might not be ready to release. So that means even if you are ready, you are not actually going to production, going to live, even if when your service is ready. So that means, like, even though you are independent deployments are not true in this case. And that means independent deployments aren't independent releases. And that is where we see that micro frontend architecture is what is trying to solve this particular problem, saying that instead of just breaking your backend, you can actually break your front-end code as well into multiple repositories, multiple front-end domains, so that a team which is end-to-end team handling the backend plus front-end part of that feature actually can deploy, can release the whole thing independently without even relying on any other team of the whole product. So that means, what are the different features or different advantages that you get from micro frontends? Independent teams. I'm just repeating the same thing again here, just to set the context. Independent releases, of course. Other advantages that your code becomes simple. Again, instead of handling the whole single monolith where every team is contributing to, you have tons of lines of code, correct? Your micro frontend is simple enough, decoupled, and is actually just talking about what feature you are trying to handle instead of like scattered among all the different features. That also means that let's say that if there is a new person joining your team, the context sharing for that particular feature or domain becomes very easy. And that also means that it is easier to do the incremental upgrades as well. For example, you don't need to wait for a full-fledged big release to go live. Instead, whenever you are ready with one particular part of your feature, since you are independent end-to-end, you can actually do incremental upgrades as well. So with that, we covered the part of, I think most of you will already know what are micro frontends, correct? And what are the advantages that we are, what are the advantages that we get from micro frontend architecture? And like these few slides cover that context with everyone. But the main idea of this talk is to also cover how to do the micro frontends. So to understand that, firstly, we need to we need to know that what are the different key decisions that you need to take or need to know before actually jumping into micro frontend architecture. For this, I have tried to split it into 5 different sections or 5 different key questions that you need to talk about, which includes firstly the slicing. So that means, again, you have a full-fledged product. How would you actually break into different small pieces, again, independent pieces? Second is composition. That means now you have sliced your product into small slices, into small pieces. How these slices should come together or get composed so that for the end user, it remains an end-to-end application, a single application. Third is communication. That means how would different micro frontends talk to each other? And a very simple example of it like if you are into a e-commerce site, correct? You try to click on add to cart, your cart gets updated, correct? That means if these two are different micro frontends, how do you make sure that one action and an action on one micro frontend actually gives data to the different micro frontend? So that is communication. Fourth is authentication. Again, this is a very common question I have seen in micro frontend architecture, that how different MFPs can get authenticated in a single end-to-end application. So we'll cover that part a bit. And last but not least, like all things are okay, correct? You understood slicing, composed, communication, authentication, but at the end of the day, your application should work as expected. So that means you have to have a very good testing strategy to make sure the whole end-to-end application is also working the way you expect it to work. So that is where you need to figure out how would the testing will work in the micro frontend architecture. So we'll go through all these points one by one, digging a bit deeper into it and giving some time to discuss the different techniques and approaches to for all those points. So moving on, the first thing that we need to understand is how do you slice the micro frontend? And here, there are different ways to figure this out, okay? When I say slicing, does it mean that whatever you see on the screen, each component that you see should each component be a separate micro frontend? Maybe yes, maybe no. For example, if let's say if you are building a application where you have a very customized calendar component, and that calendar component maybe have some information, some domain information, pricing information, and all, and handling a lot of different type of features within that component itself. That means that component actually can be a different micro frontend, can have its independent release as well. But that doesn't mean that whatever you see on the screen, each component can be a separate micro frontend. We have to think about that, correct? The whole idea of micro frontend architecture is to create different repositories. If each component ends up being a separate repository, it's not maintainable, correct? So we have to figure out what is actually can be split into different repository or micro frontend. Second thing is, can a single page be a micro frontend, or even within a page can different sections? I'm not talking about components here. Mostly sections should be micro frontends. Again, maybe yes, maybe no. It all depends upon the UX as well. So in most of the cases, you would see that each page that you see ends up being a different micro frontend. Again, consider the example of e-commerce site, correct? The cart, which mostly will show you the card details. It's a single screen and it's a micro frontend. Second thing can be your payment journey, correct? That is mostly a single screen and can be a separate micro frontend as well. So it all depends upon how do you see your different domains. And to understand that better, correct? How do you identify those domains? That is where the whole idea of bounded context patterns comes into picture. So I'll not go into details of this. It's mostly taken from the domain-driven design concept. But the whole idea here is that you figure out that it helps us with defining the boundaries of a particular entity. And it actually helps us to figure out what are the different domains in the product, existing domains in the product. So considering the example of again, an e-commerce site, correct? The whole idea of e-commerce revolves around customers, products, correct? But that doesn't mean that the entity customer, what the sales people understand and a customer is same what the support actually understands about a customer, correct? The attributes of a customer in both the cases can be totally different. And that is where you need to identify, saying that, as a sale is a totally subdomain in the whole e-commerce domain for me. So that means that can be separated as a separate microservice and as a separate micro frontend as well. And same is true for support. So if I take a real world example here, okay, so this screenshot is actually taken from Amazon. It's a PDP page, product details page. You can easily say that a single page is actually having different type of information for a product. You have an image carousel going on. You have a product summary going on, pricing, recommendation, and so on. So if we apply the concept of bounded context and try to identify different subdomains here, we can clearly see that we have product, we have recommendations, we have product information. Each color, like different color codes, represents different micro frontends or different subdomains. So if you see in this particular diagram, correct, even though recommendation also talks about products, the product summary also talk about product, but the attributes of a product that I need to show here are very different. For example, product summary needs to know about each and everything of a product that a user need to know. In recommendation, I'm just telling that, oh, given this headphones, these are the other recommendations that are actually related to this headphones, and so on. So that means if you identify your subdomains correctly in the whole product, you can actually build this kind of teams where each team is handling one subdomain for you and again is totally independent. So with that, I hope the concept was clear. With that, we actually ends up with the section 1 saying that how do we slice the whole full product. So Fred, do we see any questions right now?
So there was one question at the very beginning of the session regarding the difference between vertical and horizontal scaling that you mentioned at the very beginning of your talk. It seems that you're still scaling, and at some point the team starts to specialize with some feature set. So in terms of scaling, and there are things that the person wanted to be explained. So I don't know whether you want to keep this for the end or if you want to go back and.
No, I think the quick idea about that is like with respect to scaling, correct? We don't need to consider the scaling only for the product that you are writing, the code that you are writing, correct? The whole application should scale, but also the teams that you need to split into. So it's an evolution, correct? You start small and then you scale to bigger, and that bigger enterprise where you can actually split into multiple domains, and each domain is a vertical slice of it, but the whole product is a single domain. We'll cover a bit more about that in the end of this slides as well, covering what is a good idea of splitting the teams. So we'll cover that as well there.
Okay. A second question that is coming up on the slicing. So how do we know that the slicing is done correctly, and how do we verify somehow the slicing strategy?
Yeah. So usually, I think that concept is also taken from the microservice architecture. If you see that in your domains, in your subdomains, you have a lot of communication happening between different subdomains, correct? That means that might not be a good slice as well, because that might actually fit together. And vice versa, correct? If you see that a lot of things are coming together, which is bloating the whole thing, that might not be a good slice again. So that if you are able to slice it correctly, you will see that the whole architecture gets evolved and easy to maintain as well. I would say the maintainability is the answer. That how do you see that if the slice is correct or not? You would not see such kind of problems happening in your architecture.
Okay, it seems that questions are coming in very quickly now. So there is another one that's asks for how to identify subdomains based on bounded context. Do you envision that there will be a one-to-one relationship or mapping between micro frontends and microservices?
I'll answer this question with an example. Mostly, I think it's mostly a domain-driven design concept, which I'm not an expert into, to be very frank. But if you again, I usually give an example of an e-commerce site. Uh, if you see the whole user journey where we actually search for a product, or go to a dashboard where you see a list of products, then search for a product, add the product to the cart, and then from the cart you actually goes to the payments. So if you think about that, you can clearly see different subdomains. Maybe something like a catalog as a subdomain, and catalog microservice and a micro frontend can exist. A cart is different, and then again payments, and so on. So again, if you are able to identify those things, I think it will become very easy to manage the whole one-to-one mapping between micro frontend and microservice as well. But it is also possible that maybe your one micro frontend is not talking to one microservice, correct? Maybe you have split those into multiple microservices. Again, you see a need of it with the because of all the reasons that you can think of. So that means one micro frontend can talk to multiple microservices. If that is not manageable via a front-end code, you can always have a BFF layer in between. For example, the UI only talks to the BFF layer, which further decide which microservice to go and ask for the data. So that is another way you can solve this problem.
Okay, and maybe one last before you go on, if you or maybe
Yeah,
I should
I think
for later or
yeah, let's take it later. I think we are already behind our schedule, so I'll quickly move to the next section of it.
okay, so I'll keep for that for later. Go ahead.
Cool. So the second question now is that how do you compose? Like now we have identified the slices, correct? That has to come together to make one single end-to-end experience for the end user. And that is where we actually have different options available. One simple option is build time integration, build time orchestration, and then the other one is runtime. And runtime is further can be split into client side, server side, and edge side. We'll go into it one by one. So firstly, the build time composition of it. I think most of us know what is it. We have been using that with all the libraries that we use in our front-end code base, correct? We have node modules, which we installed as NPM packages, correct? Similar to that, what you can do is that a team, a micro frontend team can actually build its own micro frontend. But instead of running it on a web server, you actually build it, test it, and publish it to a node repository. So all the teams can do it independently, and that means each part of it is actually independently publishable, not deployable, I would say. But that means we also need an integration team, which actually consume all these micro frontends here into one application, so that application is the end application for your users. So for example, if team one is having an MFE1 published, integration team, it will just install MFE1 and use it in the actual application. Now, even though in this particular case, your teams are independent, but your deployments are not. For example, any new feature the team one is developing, correct? They have to update in the integration or in the container to release that feature. So, and that is why we call this particular composition pattern as a distributed monolith. Like even though you're distributed, but you're not independent because of it. And the idea is to use this have extreme caution when you actually think about using this particular composition pattern. But this pattern actually comes very handy when you are into a mobile, if you want to build mobile micro frontends, a cross-platform solution using React Native and all, because again, in mobile, it has to be a one single artifact, correct? So you can build different packages and then combine it to a mobile app together to work as a single application. Recently, I also get to know that in React Native, module federation, Webpack module federation also works. I haven't tried that, but that is another possibility. So moving on, so runtime composition, again, that means that you need not to integrate the micro frontends at build time, but dynamically on the runtime. That is that when the user actually requests for that particular page. And we split it into three different ways. Firstly, client-side composition, server-side, and edge-side composition. So going through it again one by one. So first, client-side composition. So it's a bit similar to the build time, but only up to this level, where instead of you are testing it, building it independently, but instead of publishing to a artifactory, you are deploying it to a web server. And then your browser is responsible to stitch the whole different parts of your application or stitch different micro frontends into a unified application. So the main idea of client-side composition is that the browser is actually responsible to call your web servers saying that, oh, I want to render this section at this section of your page. So I'll call that artifact. For example, let's say it's a React application, correct? So whenever we deploy the bundle.js file, correct? Usually bundle.js, bundle CSS. So these web servers have .js file and those CSS files. So browser actually calls that JavaScript file and actually tries to run that script on them to actually render that micro frontend. This composition pattern also needs a container team. Why? The reason being, somebody needs to call that micro frontend, correct? Call in the sense that maybe you are just saying that I know the URL of my bundle, add a script tag and load it. But where would you do that? That is where the container comes into picture. So container will say that, oh, if I'm going to /cart, get the cart micro frontend bundle and render it on the screen. And that container is also responsible for actually having your layout of the application as well. Your header, your footer, your sidebars. So the main content continue to change as you actually go from screen 1 to screen 2 or page 1 to page 2. But everything is happening on the client. Server is not there. Like whenever you load it, then you start making Ajax calls to actually get the data from the server and all. But the whole composition happens on the client. Now, to contrary to that, okay, before moving to that, there are different options available for client-side composition as well. There are different packages, libraries. For example, if you want to work with iframes, there is a project available. Module Federation have been a talk of the town since long. With Webpack 5, they came up with this concept. I think a lot of projects are using it. Then there is a single SPA. It's very, very famous, I think, framework available. Or in the end, as I mentioned, you can always write your JavaScript code. Like you can, it's just a script tag that you need to add, which will load your micro frontend. You can always do that. So now, in contrary to client-side composition, we have server-side composition as well. So consider an example of just give me a second. Yeah. So the difference between, again, a client side and the server side is that now the whole stitching of micro frontends actually happens on the server, not client. So as a user, if I request for, let's say I hit a URL, now that request goes to a web server, correct? Which will be responsible to actually further call the tag, gets the HTML for different micro frontend, stitch it together, and at the end returns the whole HTML back to the user. So client is not involved into fetching the micro frontends. Your server is actually doing that. A very simple example of this kind of a composition is reverse proxy. Correct? There is a reverse proxy sitting in front of your routing service. So if a user requests for, let's say, /catalog, my reverse proxy knows that, oh, which micro frontend will return me the catalog catalog API, catalog HTML. So it will just call that and return back the user the catalog, and so on with cart or payments and all. So that is a very simple solution. But as your project grows, you also would need to figure out like how would your layout works in that case. For example, you would have your header, your footer, your sidebars again, correct? Who will be responsible to create that kind of a layout? And that is where different libraries are available in the market, which actually helps you to do that, where there is a layout service sitting in between, which actually further calls your routing service to fetch those micro frontends at server side, build the whole page, and return it back to the user. So again, as I talked, like there are different libraries available for this composition. Few of the best examples are listed on the screen. And I think most of you would already know the project Mosaic that I think Zolando builds. They were the first one to actually opt for server-side composition, and so on. Now, biggest advantage of this kind of composition, correct? First of all, it is easier than client-side. And since the whole front-end ecosystem is moving from clients CSR application to SSR applications before of its advantages, server-side composition might be useful for better performance, for better SEO ranking as well. CSR is never good for SEO ranking, correct? Server-side is the way to go. So this kind of composition might help you there as well. Now, one of the questions should be that now I'm using Next.js or Remix. Does that mean that I can do that with Next.js as well? If each screen is a micro frontend, then it is easy, correct? You can build different Next.js application for each screens, and via your reverse proxy, you can just route it to the different micro frontends. If within the same screen you have different micro frontends, I think I was reading it today. One of the way to do that is using module federation within the Next.js app as well. But that becomes CSR. That is the disadvantage of that. So maybe this space is also evolving, but the frameworks like Remix says that we don't need micro frontends anymore because the way Remix does it work. So again, opinionated, but you can always try those options as well. The last is edge-side composition. It is a bit similar to server-side, but more closer to the client side. For example, there's still a proxy server sitting in between, but instead of the whole stitching happening on the server, when the user requests for a page, correct? There are edge-side includes available, which actually further calls the CDNs, content delivery networks, which are on edge, correct? To actually fetch that micro frontend and stitch it on the reverse proxy in like this particular server, and then returns it back to the user. So the only difference between server side and edge side is that the whole stitching happens on the server. Here there is a reverse proxy, or let's say a server sitting in between, which actually talks to the CDN further to get your content of that micro frontend via like edge side includes, and then return back the whole HTML to the user. So that is the only difference between edge side and server side. But it has a very big advantage because of CDN sitting in between, correct? And that is performance. Since CDNs can cache your pages, correct? You can always have your public caches or private caches as well. And like, for example, if I'm building a blog application, correct? My blog section can go to a CDN, and whenever user requests for that blog, I can just fetch that data from the CDN, put it into the HTML page, and return it back to the user. And that particular section can itself be a cached section from the CDN. So with that, I think we end up with the second key question, composition. So instead of like going through the questions, I'll quickly move to the other section. We'll cover the questions in the end. Now we have split the whole thing. We have composed it together as well. And the next part comes into picture is how would those different sections can communicate with each other. And that is where there are two different ways to try that out. One is storage based. Second is event based. Storage base is simple, very simple, correct? We have our storage APIs available in the browsers, local storage, session storage, cookies and all. So maybe if one micro frontend needs to pass data to another micro frontend, you can set it up in the storage and say that, oh, second, the other micro frontend can always read it. The biggest problem with that approach is that our storage APIs are not asynchronous, correct? So for example, if I am clicking on add to cart button, correct? So that means I want my cart to get updated on the same screen. But since my storage APIs are not asynchronous or not based on pub/sub kind of a mechanism, even though I'm setting on the cart, I cannot read the updated data upfront. So that means storage base is very helpful when you are actually need to pass your data from one screen to other screen. So like I can set the data in storage in one screen. I go to other screen, that screen, on load of that screen, you can always read that data from the storage APIs. And that works really well. Other way of solving the similar problem is setting that data on the URLs as well. For example, if you're just concerned about one ID that I need to pass, or maybe one selected ID that I need to pass from one micro frontend to other micro frontend, I can just set it on the URL. And on the screen, and the second screen, I can read that URL saying that, oh, I know what is the selected ID and I need to fetch the data for that. But that again, as I mentioned, that will not work when you are on a same screen, and that is where event-based mechanism is the way to go. So your browsers have a custom event APIs available in on the global object. So for example, again, whenever I want to add a product in the cart, I can actually publish an event with that product where my cart as a micro frontend is listening to it, is subscribed to that event. And whenever a user clicks on add to cart, the cart will automatically get updated because the event is passing that data. And that is asynchronous. And that is a kind of a pub/sub kind of a mechanism already available in the system. So again, decide what suits your application best and accordingly take the decision. Storage based might not be the best suited for bigger set of data, correct? A huge data. So avoid that. Or some sensitive data also, I think we usually avoid to set it up on session on local storage and all. So take decision accordingly. These kind of data actually should flow within the application only instead of being available to the browsers also. So that covers the third question, and the fourth question now we move into is authentication. So on authentication part, what we need to actually think about is that how will each authenticated micro frontend run independently? For example, a cart as a micro frontend, correct? A cart needs to know that which user is logged in so that it actually can load the products added to the cart for that particular user. But cart needs to run independently as well. So how do you make sure that independently also that my cart is getting the right token, and within the whole end-to-end application is also I'm getting the right token? And second question to answer is that how to refresh that token as well within the whole space, micro frontend space, or all on the whole end-to-end application. So I'll not go into the solution part of this, but these are the two questions that you need to answer. And one of the way you can think about it is again creating a pub/sub kind of a mechanism. This might work more like this example is mostly client-side composition driven, but we can think about an alternative on the server side as well. Where the idea I'm trying to share is that there is a different micro frontend, a user and registration micro frontend. So your MFA requests that micro frontend saying that, oh, give me the auth token, give me the auth token. And that micro frontend is actually making sure that it is returning the correct auth token back to the MFP one. So if it is valid, return it. If it is not valid, that means it has expired. That micro frontend talks to the microservice saying that, oh, given this refresh token, give me the latest give me the latest auth token back. If let's say in between your micro frontend 2 also request for auth token, it actually can check that, oh, am I already fetching the latest one? If yes, wait for it. Once I get it, I'll pass to both the micro frontends the latest token so that you can use it. So this kind of a mechanism is what you can think of. Again, this is just a proposed solution. In your application, it might work differently. But again, like try to think about how each micro frontend can run independently. Maybe when you are working locally, correct, you can avoid the authentication mechanism altogether, or maybe have a mocking mechanism saying that, oh, I'll always pass the same token which is valid. So these kind of things can also be tried. So last but not least, now everything has come together, things are working fine as it seems, but how do you test it? So, and that is where the whole idea of, I think we all know this pyramid, correct? This exists from quite some time, where we are saying that you should have a lot of unit tests covering different scenarios, but as you go up in the pyramids, there should be lesser and lesser automated like end-to-end tests, because again, they takes time. They gives like the feedback is much longer than compared to unit tests. So what idea we are trying to propose here is that maybe within each micro frontend, correct? You continue to use the pyramid approach. You have the whole thing covered at the unit and at to end at a level as well. For example, let's say you're creating a payment kind of a micro frontend, correct? Which has its own journey. You fill up card details, which will actually further give send a request to the payment gateways and then give you success back. That is one journey. So that journey can be tested end to end within the same micro frontend. But as a whole application, correct? A user doesn't start directly with the payment. Users start with selecting a product, adding it to cart, and then going to payment. And that is where we are trying to saying that there is another model, which is Swiss cheese model, again written by a thought worker. The link is available there. You can all check that. The idea here is that each hole in the cheese, correct? Let's say there is a bug. If I slice the cheese into multiple layers, the whole idea should be that bug should not traverse till the end, but should be stopped somewhere in between. So that means in a micro frontend architecture, even though you had made sure that your micro frontend is working fine end to end, but when it is stitched together in the whole application, it should also work perfectly fine, correct? So that means you need some automated way at the top level, which will make sure that whole end-to-end application is also working fine. So for example, you might need an end-to-end automation suite saying that which will cover the whole product journey or a purchase journey for a user, which will say, oh, like, okay, I'll search for a product, I'll add to cart and so on. But independently, payments or carts are doing their own journey. But at the whole application level, you are making sure the whole thing is automated. So maybe in your micro frontend, if you have added a new feature, which although is working fine in your micro frontend, but when it's stitched together, it fails. Maybe a contract has changed, which you cannot identify within the micro frontend. So that contract change is actually caught at the end-to-end layer as well. So making sure that your application works as expected. So with that, we end up with the 5 key questions that you need to answer, but that doesn't end here. Apart from these 5 things, you also have to make sure that how all these technical aspects you are going to cover when you are moving to a micro frontend architecture. For example, how the performance should work, localization, design system, correct? That is a bigger ask. Like how do you make sure that in each micro frontend, the design language they are following the same design language as well. So all these things you need to make sure you have identified the approach before actually jumping to the micro frontend architecture. Yeah. So is there any other questions, Firam?
Sure, there are actually. So we'll move back maybe to when you were talking about the client and server side composition. So first one was how to handle common libraries and CSS loading in each of the microservices.
Can you come again, please?
Oh, sorry. So how do you handle common libraries and CSS loading in each microservices?
Okay, or I would say in each micro frontend, correct?
Yeah.
So that is one drawback of client-side composition when you are actually doing it yourself. So there was an option, correct? Write your own 20 lines of JS. Where since each micro frontend is independent, correct? Let's say each micro frontend is on React. So that means independently they are loading the React as a library as well. One way to solve that problem is saying that again, I'm talking very specific in terms of Webpack, but I'm pretty sure the other bundlers will also have that capability. Saying that whatever is a common library, correct, that is a external to me. Webpack has a configuration saying externals. That means whenever it actually tries to import React, it will actually skip it in the end bundle. So that means the whole bundle does not have that common library. So your container actually needs to load that library, maybe in the script tag or whatever the other way you would like. But one of the biggest problem in that is that you have to make sure that all the different micro frontends are on the same version of that library. And that is exactly how module federation also works. Okay, module federation also have a configuration saying that these are the shared libraries, but it also says that make sure that your shared libraries are on the same version. So there are ways to solve that, but it has its own limitations as well. But again, so imagine that you are on a migration type of a project. You don't need to worry about that from the day one, because you are actually, let's say, migrating from Angular 1.x to React. You actually want to load the both the frameworks at one page and slowly move towards this type of performance improvements and all. For the CSS, same thing applies to CSS as well. Make sure there's no ambiguity in the CSS class names as well to avoid overriding of your styles and all.
So there was another question, a second question, somehow in the same line. So how do you sandbox applications from one to another? For instance, not all frameworks and libraries will operate harmoniously, okay, within the same runtime. So that's just what you somehow explained, that you need to have a very same version of the shared libraries and so on. So far we've identified the following strategies to sandbox micro frontend application from one another: SSR/age composition, iframes, shadow realms, and this type of things. Could you elaborate on this? So how do you sandbox the micro frontend application from one another somehow, even though they're somehow sharing libraries or not? I mean,
so I feel when you create a bundle of a micro frontend, correct, it's already sandbox within that bundle file, correct. You don't need to worry about till the time there is a library which is not exposing methods on window, because if it is, then it might end up overriding the whole thing. But again, within one micro frontend, if you are using a particular version of a library and the other micro frontend is using other, I don't think that will cause any problem. Again, something to check about, but I doubt that will cause anything, because the whole bundle that all these bundlers create, correct, they are actually wrapped inside a IFI. So making sure that it is not exposed at the global level. So that is my understanding. Other thing is, recently in my current project, correct, what we realized is that web components, even though it has a lot of advantages, but I see a lot of problems with it as well. For example, it actually causes a lot of layout shifts because web component needs to get registered on the client, correct? So that means even if you are fetching that web component from the server, till the time it is not registered on the client, you actually clearly see a layout shift or a flash of unstyled components as well. So make sure that you see all these, you consider all these problems with that as well. Maybe not the perfect answer to your question, but these are few things I'll try to manage.
I think you already answered some part of the following one, but just in case. So why does the build time composition and will become worse than a monolithic one? Is there a way to avoid those kind of problems?
So build time composition actually gives you way to segregate your code than a monolith, correct? I'll talk about what are the other ways also in the end of this slide. We are already behind our time, but uh, you are able to segregate your code, which can be independently tested. But since it has to be integrated in a container application, correct? You have to actually publish a new version for each and every single update you do on your micro frontend, correct? It doesn't automatically gets updated on the actual end-to-end application. So that is where we are saying that it might not be a best fit. If you have options, other options to use runtime composition, go for that. If you don't, then build time is a way which you can always try.
Okay. I'll give you a few more minutes to go on with the slides because I know, I mean, this has been a quite interactive session. There have been many questions, so we will allow you additional time. Don't worry. So go ahead with your slide.
So moving on, so the last section, as we discussed, correct, we will talk about a bit about the team formation as well. So, like following what we discussed in the slicing part, correct? If we follow the bounded context principle, make sure you are building teams following the domains that you have identified. Again, one team can have one application or one MFE, one end-to-end MFE. I think somebody just started a poll. We just need to wait for 5 more minutes for this.
Yeah. Just think we need to bring up the poll before the end of the session. That's the reason why it was brought up. So don't worry about it. Just keep on with your slide.
Good. So the proposed idea here is that at the program level, correct, you can have your leads, you can have your product owners, business analysts, QAs and all. But at the team level also, you need all those roles. You have to have a team lead, which is a domain expert for you, correct? Which knows end to end about that part of your application. You need to have a domain expert for your as a product owner as well. So these kind of a team works really well. But after splitting, this cannot be a good team, correct? That is where we are saying that always go for the vertical slices, not for the horizontal slices for team splitting. For example, you should not create a team just for handling the styling of your application, correct? But each team should handle the styling as well as your business logic and all. So that is where you will actually get the vertical teams. But with that, there comes a lot more other things that you need to think about, correct? There has to be some shared guidelines within all these teams. The teams needs to speak the same vocabulary. They needs to understand what is the overall domain that you are working. They have to agree upon that what is the responsibility of one team and what is the ownership of that particular team. Major thing, I think most important point is that you have to maintain an area which is decision records. Why are you actually taking this architectural decision, and will it impact other teams or not? So you have to have those ADRs written somewhere and getting approved from your architects as well, so that you know that why this particular decision was taken. Last but not least, as your application grows, as your product grows, correct, and you started seeing the need of more micro frontends. If possible, try to create a scaffold of it as well. For example, create React app is a scaffold to spin off a React application, correct? If you have identified the sensible defaults for your product, correct, try to create a scaffold for those sensible defaults so that next time, whenever you need to spin up a new micro frontend, you can just use that template and you're ready to go. And in this kind of a structure, correct, the team guilds also makes a lot of difference. So what team guilds is like where a like-minded people actually come together and share the ideas. For example, a very common team guild folks might have worked with this, like design guilds, where your designers, your UI devs, your team leads comes together and figure out that if I need to create a design system or a design library, what all components should be a part of that design system, correct? Similar to that, you can actually figure out what is your analytics guilds, maybe your accessibility guild. We usually nowadays have started calling those as COPs, community of practice, accessibility community of practices and all. So all these things comes very handy because you are working in a distributed type of architecture. So all needs to come together to figure out what is the best for the whole product as well. So this is the end part of this talk. Like, should I go for micro frontends or not? So what you need to identify here is that with all those advantages of micro frontend, correct, there is a complexity attached to it. And which means like it actually takes relatively longer to provision and set up a MFA infrastructure, correct? If you have a monolith, you just need to create one CI/CD pipelines and a release pipeline, correct? With micro frontend, each micro frontend has to have its own infrastructure setup. It has to have shared dependencies, correct? And it actually costs time also. So it's a trade-off between time and cost. It gives you advantages in longer term, but maybe not in the start. It will take a lot of cost to set that up also. So before choosing the micro frontend architecture, the practical factors you need to consider is that do your project has that bigger a scale or not? For example, if I am building an MVP, correct, or I just need to create a POC for my client so that I can win a project, maybe MFE is not a right fit here, correct? You will end up spending a lot of time to spin a micro frontend rather than actually concentrating on your business stories or features. So that might not be a best practice to start with a micro frontend if your project scale is very small. Secondly is that you can clearly see subdomains in your whole product, correct? Then it makes sense to consider splitting it the whole application into multiple smaller apps. And other two things I think is related to the first 2 points. If you know that your team size is increasing, it is very hard to maintain a big team by working on the same code base. It's better to split them up into different domain teams. And if you are migrating from a monolith, I just touched upon this point as well, that migration from one framework to other framework, micro frontend is a very good fit to do that. So that is another decision-making factor for you. If you don't want to do micro frontends from day one, another way where you can actually slowly move towards micro frontend architecture is like start with a monolith, but create clear separations between subdomains. That means you can actually opt for feature-driven architecture, correct? Each feature, the whole code for one feature is sitting in one directory only, or monorepos as well. I think monorepo is actually again gaining a lot of attention. So monorepos is another way to start with. And if you have split that into subdomains, correct, in your monolith as well, later on, if you see the need to move to different repositories, it is very easy to do that if you have done it correctly from the day one. So you can slowly migrate to the micro frontend architecture also later on if you don't want to do it from the day one. Yeah, with this, in the end, I just want to say that, like, with all these things that we discussed, micro frontend is a marathon, not a sprint. So think about if it is a good fit for you. What are the different aspects you need to solve, and have a discussion within your team that, oh, we think micro frontend is a good fit, good architecture for our problem statement. So have those discussion before jumping into the architectural directly. And with that, I'll just share, I have just references where you can all go through to read more about micro frontends and all. We have done some sessions in the past as well regarding testing strategies, different ways to communicate between micro frontends and all. We also did a webinar, a 3-hour webinar in ThoughtWorks to actually do discuss about all these aspects in details as well. So this is a link for that as well. So with that, thank you. Thanks all for your concentration. I hope you would have liked the talk. So yeah, that is it. Cool. Any other questions that we need to discuss here?
No, actually, we got covered them all, so I think we're done. A big thank you to you, Vishal. That was a very interesting session. The last session is, can you please forward this PPT? So yes, the PPT will be made available on the website as a PDF file, if I remember well. So if you check the very early links that we provided in the Q&A, you will find the replays pages for all the different meetups that already occurred, and this one will be added shortly. Just give the time to Didier to come back from his day off, I would say, and all the video editing of this session. And once done, he'll be publishing the replay on our website, and the content will be made available there. So you'll get everything you need for this. So thanks again, Vishal, for this session. It was really interesting. We went over a bit in terms of time, but I think that was worth it. There were quite a few questions, so thanks again. And I wish you all a very good end of your day, wherever you are on Earth. I mean, it could be Europe or America or wherever else. And I'll be very happy to see you all in a forthcoming session next month in May with Didier and the rest of the HP Dev team. So happy day to everyone. Goodbye and thanks a lot. Thanks, Vishal.
Thank you.